Hi, here is a nice improper integral. It's set as I from 0 to plus infinity x over e to the x minus 1 dx. Okay? Just pause this video if you would like to give it a try to this problem. When you worry, come back to see the full solution. Okay? Let's get into the solution now. If you take a look at this integral, as long as we have the bound from 0 to plus infinity, this integral is challenged because we cannot apply the substitution or by part. Right away, we have to make some changes before we start evaluating this one. So now, in order to simplify this integral, we are going to rewrite this integral as from 0 to plus infinity. I'm going to multiply numerator and denominator by e to the minus x. So I will have x is multiplying by e to the minus x. Okay? As you multiply denominator by e to the minus x, this one become 1. Second term become e minus e to the minus x dx. Okay? So what I'm going to do now, I'm going to add number 1 and subtract number 1 in the same time. Now by simplifying this one, so I will have this integral from 0 to plus infinity. I will have minus x because the numerator is e minus x minus 1. Underneath I have 1 minus e minus x. That's mean I put minus sign in the front. So I will have minus x plus x over 1 minus e to the minus x. The whole thing is dx. Okay? Whole integral. So I have the, now what I'm going to do now, I'm going to separate this integral. I will have two integrals. So I integral become from minus x dx plus another integral which is from 0 to plus infinity x over 1 minus x dx. The bound from 0 to plus infinity. So it's more clear now to have the substitution. Okay, so I'm going to put t equal to e to the minus x as a substitution. I'm going to differentiate this one. See this one, I will have dt equal to minus e to the minus x dx. Okay, so here minus x equal to the natural log of t. Okay, now I'm going to plug all this information into these both integrals. So I will have I integral for the bound. If you plug 0 into the x, is giving you 1. If you plug plus infinity into the x, is giving you 0. Okay, minus x become natural log of t dx, as you have here, dx equal to minus dt over t by replacing e to the minus x with t. Okay, so dx, I will have minus dt over t as we have here, plus this integral from 1 to 0 by replacing x. I will replace x with minus natural log of t, minus natural log of t as you have here, over 1 minus e to the minus x, it become 1 minus t dx. I will have minus dt over t. Okay, so now I'm going to change the bound. With this minus sign will be cancelled out. I will have from 0 to 1 natural log of t over t dt. Second integral, I'm going to I will have this minus. I'm going to change the bound. With this minus sign will be cancelled out. So this sign minus, this minus will be cancelled with this minus, become plus. By changing the bound of this integral, now I will have minus from 0 to 1 I will have this integral from natural log of t over t, 1 natural log t over t, 1 over 1 minus t dt. As you see here, this term will be replaced with the sum of t to the n as n goes from 0 to plus infinity. This is geometry series as a convergence series. Okay, that's why I replace this one with this one. So now, in the same time, if you take a look at here, this one equal to 1 plus the sum of, as n goes from 1 to plus infinity, t to the n. Okay, just plug in 0 into n is giving you first term 1 plus the rest. Okay, so I'm going to replace this one. Before I replace this one by this, if you take a look at here, this term is the same as this term. Okay, so I'm going to put this term as a common factor, so I will have 1 minus this term, which is 1 over 1 minus t, natural log of t over t dt. As we said, we are going to replace this one with this one, so I will have my integral from 0 to 1, 1 minus this term, which is 1 plus the sum of this geometry series t to the n as n goes from 1 to plus infinity, is multiplied, the whole thing is multiplied by natural log t over t dt. Okay, now this integral, this number 1 will be cancelled out. Okay, so I will have this integral minus from 0 to 1 the sum of t to the n is multiplied by natural log of t over t dt as n goes from 1 to plus infinity. As long as we have this geometry series is as a convergence series, now is allowed to take this sum notation outside of this integral because of convergence. Okay, so now minus, I will have minus the sum of this integral from 0 to 1, the sum as n goes from 1 to plus infinity is multiplied by this integral from 0 to 1. This t to n, it will be cancelled with this t. One of the t will be cancelled out, so I will have t to the n minus 1 natural log of t dt. Now I took the sum sign outside of this integral, is multiplied by this integral. If you take a look at here, these two terms is written on the form of 2, is a product of two functions. Now it's simply allowing us to apply integral by part. I'm going to bring this one at the top and continue with our problem. Now let's call this integral as a g integral. So this g integral, we have from 0 to 1 t to the n minus 1 is multiplied by natural log of t dt. I'm going to set v equal to natural log of t and du equal to t to the n minus 1. Okay, I'm going to apply by part, so I'm going to look for the primitive of this one. I will have 1 over n t to the n is multiplied by natural log of t, the bound from 0 to 1, minus another integral which is 1 over n is multiplied by t to the n, because of the primitive of this one is multiplied by a derivative function of natural log of t, which is dt over t. Okay, so one of the t will be cancelled out here, become t to the n minus 1, bound from 0 to 1. Okay, if you take a look at this term, This, if you plug number 1 into here, is giving you 0 because natural log of 1 is equal to 0. But the second one, as you plug in 0 into these two terms, because it's indeterminate form, I'm going to apply Opitler rule. Now I'm going to apply the limit here. So the limit, this term becomes 0. So this term will be 0. I will have only this term left. So this integral is minus 1 over n is multiplied by 1 over n. The primitive of this one is t to the n from 0 to 1. Okay? If you plug number 1 here, giving you 1, minus 0. Okay? So we'll have minus 1 to the n squared. Now this integral is minus 1 over n squared. Okay? Now I'm going to bring this one at the top and summarize this one. Now the integral I equal to the sum as n goes from 1 to plus infinity, t to the n minus 1 is multiplied by natural log of t dt, because we found this integral equal to minus 1 over n squared. This minus sign will be cancelled out with this minus sign, so we'll have plus here. This one is more famous sum, okay, equal to pi squared over 6. If you want to know how to evaluate this one, just go to the previous video, you will see all the details. This one you can apply the Fourier series or Maclaurin series, okay, either one. Now I have done with this problem. Just consider the subscribe. If you have any question, just put it in the comment section below. Okay, thank you for watching. I will see you in next video. Bye.